everyone, welcome back to my video. I'm glad to see all of you today. How's it going? I hope you're doing great, and let's explore our lesson today. Now, I have 4 sentences for everyone. 1. 1 plus 1 equals 2. Sentence 2. How old are you? Sentence 3. 9 is a prime number. And sentence 4 is a wonderful day. And look at the board and answer 2 questions. What kind of this sentence? And we can determine the 2 values of each sentence. And let's do it together. With sentence 1, we have the declarative sentence. And we can determine is 2 because 1 plus 1 equals 2. With sentence 2 is a question. It's a question, so we cannot determine the 2 values of these questions. And now next one, 9 is a prime number, is a declarative sentence, and it's false. Yes, 9 is a composite number, not a prime number. And with the last one is a wonderful day, is a comment. And we cannot determine the 2 values of this comment because with me is a wonderful day, but with you is not a wonderful day, right? So be careful to sentence 1 and sentence 3. In mathematics, we call the proposition. Now let's explore a lesson today. Proposition and set. Chapter 1. Proposition and set. Unit 1. Proposition. Now let's move on to part 1. Definition of proposition. Now look at again sentence 1 and sentence 3. What kind of sentence is the declarative? And we can determine the 2 values immediately, right? Sentence A is 2, sentence 3 is 4. So each sentence has exactly 2 values, so it's called a proposition. A proposition is a declarative sentence that has exactly 2 values. It means its proposition is true or false. We cannot true or false at the same time, right? And we can determine, we can denote the proposition by the capital letter. A, B, C, and so on. Now let's do example 1. Now, which sentence is the proposition, and if is a proposition to find the two values of x. Seven is an odd number. Odd number. Sentence 2. What time is it? What time is it? Now, before we answer those questions, you can to reread the definition of proposition. A proposition must satisfy two conditions. First condition is the declarative sentence. The second condition is that has exactly two values. So if they have two conditions, it's called a proposition. Now let's apply to the sentence 1. Sentence 1, 7 is an odd number. Is a proposition because it's a declarative sentence and we can determine two values. 7 is an odd number is right, so is 2. So we call the proposition A. Is 7 is an odd number. It is a proposition and is 2. Is 2. And with sentence B, sentence C, sentence 2. What time is it? Is a question. So 2 is not a proposition. Okay, now I have another example for one. Now look at the drawing and be careful about this. A is greater than 5. Now, answer two questions. Is this sentence has variables? And can we determine the two values of this sentence immediately? Well, so with the question 1, we can see we have the variable x here, so it has one variable. And we cannot determine the two values of this sentence immediately, right? Because it depends on x. If x equals 5, so I have 5 greater than 5 because I plug x5 is equal 5 right here. So I have 5 greater than 5 is false. And if x equals 6, 6 greater than 5 is 2. So that means in mathematics we call this sentence is called the open statement. Now let's move on to part 2. Open statement. Statements. And we call the statement here is P of x. It's called the open statements. And open statements is a declarative. So and their two values depends on the values. So there has one or more variables like this. Now, I have a problem. And inquire go on the street and inquire see the traffic sign. So what said? So what said? What says this is a traffic sign prohibiting parking and stopping. But Anne doesn't agree with Y. So what could Anne say? So Anne can say this is not a traffic sign prohibiting parking and stopping, right? So we can can see the opposite side with and inquire, and we can say and. The sentence and say is the negation of the sentence quite say. So let's move on to explore the next part is negation. Negation of statement or negation of proposition. Now, definition. Let P be a proposition. The negation of P denoted by not P bar. P bar is called not P. Not P. Denoted by is a proposition. Proposition that has the opposite two value of P. So that means if P is 2, then P bar not P is false. If P is false, so P bar is 2. Is 2. So I have an example for one. So now I have two examples. And the first problem. Now example 2. Find its negation and its two value of this sentence. Sentence 1 I call is this proposition A. Sentence 3 is called proposition B. Now let's find out the negation of the proposition A. I denoted not A. A bar is 1 plus 1 is not equal to 2. And the negation of B is 9 is not a prime number. And to determine the two values, you can to determine the two values of its original statement like this. A is the 2 value, so A bar is 4 because the 2 value is the opposite. B is the false statement, so B bar is 2. Right? We understand? Yeah. Now let's move to the problem. I have some sentence for everyone. Now, who remember the theorem like this? If triangle ABC is a right triangle, at A, then the triangle ABC has AB squared plus BC squared equals BC squared. Remember which theorems? Yes, that's right, it's a Pythagorean theorem. So we can see in this sentence we have two clauses. The clause after the letter if is called P, and the clause after the word then is Q. So we can write if P then Q. And in mathematics we call this implication statement. Now let's explore the new concept, the implication statement. Now, implication statement has the form definition. The implication statement has the form P implies Q, and read that. If P then Q, and P is a hypothesis. Q is called conclusion. Now, let's do some example. We can write some example as the form implication statement on your notebook, right? And now with the two value of implication statement, we can remember, it's very easy to remember, P, if P then Q is only false when P is true and Q is false. And each other case is the implication statement always true, right? It's easy to remember it. Now, what happened? What happened if I swap implication statement? If I swap, I have the Q implies P. If Q, then P. It's called the converse of an implication statement. Now we have the section 5, converse of implication statement. The converse of implication statement P and Q is Q implies P. So we can write the converse of P implies Q is Q implies P. So we can see the converse of implication is an implication statement. So the two value is the same with P implies Q. Okay. Now let's do example. Example 3. Now find. I have example like this. Here you can see it. It means the P. If P and Q. Now find the converse. Find the converse of its implication. If triangle ABC is a right triangle at A, then AB squared plus BC squared equals BC squared. Now find the converse of it. P implies P. If Q, then P. If Q is here, if triangle ABC has AB squared plus BC squared equals BC squared, then triangle ABC is a right triangle at A. That makes sense? Yeah. Now, I have a question for everyone now to determine the two values of P, the implication P then Q, and Q then P. because we know that is a Pythagorean theorem. So P, if P then Q is 2, P then Q is 2, and Q, if Q then P is 2, is 2. So we call P and Q is equivalent statement. Yes. Now move on to part 6. That's it. Equivalent statement. Equivalent statement. And if P then Q and if Q then P are 2. So then P and Q are equivalent statement. So we denote it by the notation P, Q, and we read that P. The notation like this is called P if and only if Q. Or sometimes you can see someone is very quickly like this with double F. And now let's rewrite example 3, 2, 4. Now we write the Pythagorean theorem. We have triangle ABC is a right triangle at A if and only if AB squared plus AC squared equals BC squared. So that's my sign. Now let's move to the last question. The last lesson today is the statement with quantifiers. We have 2 quantifiers in this section. The first quantifier is right with notation like this, and it's called for all. Now in each statement we can write a statement like this: all for all x px. Now I have the tricky for everyone to easily remember the notation here. Now look at the word all. You take the capital letter A and you can upside down. You get the notation like this, right? And it's for all. Example 5. How do we read this statement in English? Now take you 10 seconds to think about it. Yes, we can read for all real number x, so that x squared greater than 1, than 0. can we determine the two values of this sentence, of this statement? Because we have the notation for all here, so that means we have all real numbers that satisfy this identified. Okay, so we can try some special values like x equals 0. Plug it into the identifier. We have 0 squared greater than 0 is false because 0 equals 0. So we have the one case that makes the statement is false. So that means the statement, the proposition is false because we have the notation for all here. So that's why we have all real number must satisfy this identifier. Okay, it's 2, so that the statement is true. But no, we have the case 0 equal x equals 0 is that makes proposition is false. So we say the statement is false. Now, the second quantifier is right like this, and it's called for exits. So I have a trick key for everyone here now to notice the letter exit. So take the capital letter E and turn it around so we get the notation like this. It's called for exit. So we have in statement we can write exit is keywords. For example, exit is belong to real number so that x squared equals 16. So how do we read? How do we write? We read it in English, and can you determine the two values of this statement? Yeah, and we can rewrite for exit. Real number x. So that x squared equals 16. And to determine the two values of this statement, we can see in this statement has the quantifier exists. So that means we just want value is satisfy this equation. So we have x equals 4. So 4 squared equals 16. Or you can find another value, negative 4. Negative 4 squared equals 16. So that makes the equation is 2. So we say the statement is 2. So notice in statement with a axis notation we can have only one value that makes the statement 2. So statement is 2, right? And the last one, I will introduce you the negating of statement with quantifier. For all x, px. So the negation of this statement is exit x, px1. And with the statement has the exit is px, qx. The negation of this is for all x, not p. Okay, now let's find the negation of its statement with the quantifier. Here, now, right? The negation. I call the statement is P. So P bar is for all. So the negation is exit. X belongs belongs to R x squared. Now the negation of greater than is less than or equal to 0. And the true value is 2. Because the original statement is 4. Now, and the last one, find the negation of the statement with the quantifier exit. I call the statement Q. So, not Q is the negation of exists is for all. For all is belong to the real number R x squared. Now the negation of equal is not equal. 2. And the true value is 4. Now the original statement is 2. Right? So remember, the negation of greater than is less than or equal to. The negation of equal is not equal. And we have so many kinds, so many ways to the negation. So you remember, when you have the negation, you can add or cancel not. Okay? Right? Not greater than is mean less than or equal to. Not equal is not equal here, like this, right? Now let's summarize our lesson today. Today we learned too much concept in mathematics, so I hope you can understand and our lesson today with the proposition, the negation of proposition, open statement with implication statement, convert of implications, equivalent statement, and statement with quantifier. So it is too much knowledge today, so I hope you can understand. If you have any questions, let me know in the comments. And thank you for watching my video today, and see you in the next video. Goodbye.